in order to solve this, we first have to find the LCD. And what I do is I first look for the biggest denominator, which is right here. And then I look at the other denominator and think, do I need anything else besides this? And what you should notice is that has everything. Doesn't this denominator have that in it? So I'm going to multiply the LCD of h plus 1, h plus 3 times every single numerator. Every single numerator is going to multiply by that lowest common denominator, which was the second fractions denominator. And once I multiply by that, I don't know why I put 8 there. That should be a 3. All right. Now, can you divide out pieces that disappear? Meaning, does that divide out? That gone? And doesn't that also disappear? We're going to still be left with kind of a lot of baggage. Meaning, don't we have 1 times this? Plus, ooh, there's a lot of baggage here. I can do all that. Look at all that stuff. So let me do a little simplification here. Actually, it's a big step. If I FOIL this, watch what happens. I'm left with a 4 still in front. But when I FOIL this out right here, I get h squared plus 4h plus 3. That's kind of, I FOILed it out. That's what you get inside. And then over here, you're left with a 2, and don't lose that little negative right there. That little negative, it almost looks like part of the line, doesn't it? So that's negative 2 because nothing else is left on top. So that equals negative 2. Whoa, okay, got a lot there. That's a pretty big mess still. Now we got to solve it. So let's clean up all this junk right here. Let's clean up this side. So what I'm going to do here, I'm going to distribute the 1, and I'm also going to distribute the 4. So the first piece becomes h plus 1, and the second part becomes 4h squared plus 16h plus 12 equals negative 2. Now it's still not cleaned up. I just distributed those pieces. I still need to clean this side up. So I have 4h squared to start with. And then if I combine these h's, doesn't that leave you with 17 h's? And if I combine this and this, that leaves me with 13. All right. Okay, I'm finally kind of clean. But in order to solve an h squared, you want to make it equal to 0. It's kind of a different technique. You don't get h squared equals, you get everything equal to 0. It's a different method when you have h squareds. So I got to get rid of this and move it over. So I'm going to add 2 over. And I now have 4h squared plus 17h plus 15 equals 0. All right. We multiply by the LCD, got this. Now we clean this all up, and now we have to solve it. Even more work to be done. Great. Alrighty, so we are now going to solve this. So I need to factor this to solve it. To factor it, I'm going to multiply these together. I get 60, put the 17 on the bottom, and you should know, hopefully you can agree with me, that it's 12 times 5 is 60, and 12 plus 5 is 17. So to factor this, I take the 4h squared plus 12h plus 5h plus 15 equals 0. Now, I might be like, what did I just do? I took the front and the back, right here and here, and I replaced 7h with these two numbers. Those two is what I replaced the 17h with, because now I'm going to pull a GCF out of these two. So if I pull a GCF out of the first two pieces, I pull a 4h out, and I'm left with h plus 3. That's a GCF I pulled out. Then out of the second two pieces, I pull a 5 out, leaving an h plus 3 again. It's a GCF. Equals 0. Again, what I'm doing is pulling GCFs out of both pieces. It's a kind of a lengthy factoring technique. These two pieces should always be the same, and they are, so we're on the right track. So I now have h plus 3, which is a new GCF, these two things, times the GCFs that are left over, which are 4h plus 5. There should be a plus there I forgot to put. Sorry, that plus 5 should be right there. Alrighty. Okay, so I factored this, and I'm now here, and I'm still not done. I need to still find these zeros. What makes this 0, and what makes that 0? So what I still have to do is go, what makes this 0, and what makes this 0? So what makes the first one 0? Well, h is -3. What makes the second piece 0? Let's see what happens here. Solve this. Okay, we divide by 4. So h equals -5/4. So those are my answers. But did we check for restrictions? Go back to the original, because one of these answers might not work, and I will tell you, one of them doesn't work. Watch what happens. Go all the way back up to the beginning. See this? My restrictions, my domain restrictions, restrictions, can't spell all of a sudden, is h plus 3 equals 0, so h equals -3 is a restriction. So don't have to cross that out. And also, isn't h plus 1 a restriction, which is h is -1? Aren't those my restrictions? So I crossed that one out. That doesn't work anymore. Is this one of my restrictions? No. So that right there is your answer. Crazy amount of work. You had to multiply by the LCD. Get this mess right here. All the way down to here. You had to factor. Great. Then you have to solve. Great. Then you have to check restrictions. Great. It's about as long a problem as you get in math in this class. In order to solve this, we need to first look for the LCD to multiply each piece by. When you look for the LCD, what you notice is you take both pieces because they're not the same, they're different, and there's only 2, so basically both of these together are the LCD because they're both different, they don't share anything in common, even though they kind of look like they have a 1 in common, but there's a plus or minus between. So what we're going to do is we're going to multiply everything by both denominators, which would be v plus 1, v minus 1. You're going to multiply this right here times v plus 1, v minus 1. And you're going to multiply by v plus 1, v minus 1. So we took both denominators, made it LCD, and multiplied every piece by it. And watch out. Here we go. Lots of cancellations. Or not lots, but some. Can you see that disappears? As well as this. Oh, sorry. This disappears. I went to the wrong one. What we're left with then is these 2 are left over here. These 2 are left, and all of this is left. So you have a whole bunch of foiling to go on. So what you have is you have v minus 1 times v plus 4 still equals, and you have v plus 5 times v plus 1 still. And then you have the -1, and I'm going to FOIL this one because it's nice and easy to do right now. Oops, like that. So I have v squared minus 1. Kind of messy, huh? So these are left right there. These are left right here. And I FOILed this, and don't forget the negative right there. Oh, should I put -1 maybe? A little bit easier to see that right there. So to finish solving this, I needed to FOIL this and FOIL this, and then combine this. So here we go. I'm going to FOIL this, and I get v squared plus 3v minus 4. I'm going to FOIL this, or multiply it, and I would get v squared plus 6v plus 5. And here I'm just going to distribute the negative. Got negative v squared plus 1. All of that from this big mess of green. Then I got to clean up both sides. This side can't clean up, but this side can. Over here, I am going to combine the v squareds and combine 5 and 1. So what I now have is v squared plus 3v minus 4 equaling the v squared and the negative v squared disappear, leaving you 6v, and then 5 plus 1 is 6. So now I got to solve this. And to solve it, since I have a v squared, I need to set it equal to 0. So I need to move these two over. So I'm going to minus 6v right here. And I'm going to minus 6 right here. So these are gone, leaving me with v squared minus 3v minus 10 equaling 0. So I now have a quadratic equaling 0, which I'm going to use factoring to solve. So with factoring, I'm going to put the negative 10 on top and the negative 3 on bottom, which looks like, what, negative 5 and 2. So that's v minus 5, v plus 2 equals 0. So what are the answers going to be? Well, what makes this 0 and what makes this 0? So your answers are, well, 5 would make 5 minus 5 0, and negative 2 plus 2 would get 0. So those are my answers, but are either of these going to cause the denominators to equal 0? Are either of them restrictions? And if I look at it, 5 plus 1, no. 5 minus 1, no. 5 does not make the bottom 0, nor negative 2. Negative 2 won't, so our answers are okay. You always want to check to see if there are restrictions. Our restrictions would be negative 1 and 1, but those aren't negative 1 and 1.